Okay, what is HIL testing? Our next topic. I love how this National Instruments article explains HIL testing, and I have always used this to explain HIL testing theoretically. I'm not going to read this. As you can see, you have a computer and devices connected, so you can test the software on the hardware, simulating the rest of it. Let me explain HIL testing in my way, in my own practical way. The way I break it down when I talk to students at intern recruiting events, or even when I try to explain it to my parents. Imagine I need to test all the software and the hardware in a self-driving car or a whole audio product like a soundbar. I can't just like park a car next to me in my remote home office. And when each AV is so expensive, we cannot afford to hand out cars to every engineer who's working on it. That's where the hill benches come in. Instead of testing on a physical car, we set up a hill bench, a controlled test environment where we connect a device under test, we call it DUT, to a test runner running on a computer that will simulate the real world conditions along with other accessories. For example, if I'm testing a sensor, for example, in a car, I place it on a bench, simulate the rest of the system, run tests to verify its interfaces and functions. And then I do the same thing for two devices connected together if they are supposed to interact with each other. And then multiple subsystems integrated together, I will test them. And then all the way up to testing a fully integrated system. For example, it could be a wireless soundbar or an entire autonomous vehicles. Now, all right, let's talk about why hill testing is such a game changer. What are its benefits? First, it helps us to identify issues early, way before we integrate everything into a full system. This means we catch problems when they are easier, and it's cheaper to fix when it's easier and earlier. Next, we can simulate real world conditions, as I said, while combining software and hardware. Instead of waiting for a real test system, real vehicle, or a physical setup, we test everything in a controlled environment over and over again, so we can repeat it. And most importantly, we can test safety functionalities without putting anyone or anything at risk. We can simulate some dangerous scenarios like brake failures or sensor malfunctions or without actually causing harm. So in short, HIL lets us test smarter, safer, and way more efficiently. HIL testing is powerful, but it's far from easy. It has some pitfalls. I talk more about it in some of my test blogs. If you're curious, I have a website where I post some blogs.